In this video, I will go over the written homework 2.8 questions, some of them. Okay. We did number 5, 6, 7, 10, 11, 12, 13, and 14. Start with number 5. Number 5 is giving you a graph, and then I want you to sketch the graph of upward velocity of the helicopter. So sketching the graph means the velocity means I want you to find the slope, the instantaneous slope at each point. So basically is I want you to draw the first derivative graph for me. Now I'm going to draw the approximate graph. We need to analyze it before we draw it. 5 and 10. So the graph starting in here. Something like that. So when you look at the graph, we need to find all the critical points. First of all, we know that here is going to be our local maximum, even global maximum. That means we're expecting at that point is about 3 or 4. Let me take a look at the graph. 3, around 3. So here we have our maximum. Think about it. We are drawing a graph for the first derivative. That is our velocity graph. Well, this is a critical point. That means we're expecting that at here our first derivative is equal to 0. And this somewhere around 5 is our inflection point. Okay, and then the graph was separated into 3 sections. The first section, this is increasing. This part is decreasing. This part also decreasing. Okay. Another thing is, if it's increasing, means what? The first derivative is going to be greater than 0. If it's decreasing, the first derivative is going to be less than 0. So now we can draw a graph about the velocity. Oops. Okay, 3, 5, 10, starting from 0. Okay, we know that at x equals to 3, the point equals to 0. If x equals to 0, and then as you can see, the graph is growing, and slow down is growing. So that means all the first derivative is going to be positive, but it will slow down until it hits 0. So they moved the point, sorry. So here is our maximum point. We know that at maximum this equals to 0. And then for the rest, this is our inflection point. In general, inflection point should equal to 0. So that means the graph should be below the x-axis, because like I say, the first derivative, if it's decreasing, it should be a negative number. So we're looking for a negative number. And at the inflection point, here should be a 0. And then we go back right up. And then the speed just pause. So the graph we're looking at something look like this way. Okay, now the second one. We analyze the graph in the same way. Number 6. Sorry. So I have 5 and 10, 100, 200, 300, and for the graph number 6 is going down. Oops. Going down. Oh, I don't like the new ones. Okay. Going down around 4 and then go right back up. Well, this one is really obvious. It's an inflection point, also the local minimum, because concavity change. This is from concave down, become concave up. But we don't need to discuss concavity in here because we're trying to draw a graph about the first derivative. We just need to worry about, hey, this is decreasing and this is increasing. Increasing means f prime of x greater than 0. Decreasing means f prime of x less than 0. At that point, maybe s equals to 4, f prime of x equals to 0. So when we draw in a graph, we should have at 4, 5, at 4 it should be equal to 0. Decreasing means the prime is equal to 0, so f prime of x is negative before 4, and then after 4, this has become a positive. So that would be the graph for the second one. Now, number 7. Number 7 is very interesting. We have a flat line. What does flat means? Okay, let me draw another graph. So we're starting from here, flat, and go back down. 10, 5, here is about 2, here is about 8. Okay, with our previous experience, you already know that this part is going to be positive above x-axis. This part is going to be negative. Oops. So that means it's below x-axis. So what does this mean? The flat line. Look at the slope of the flat line. This is a horizontal line. So that means if it's a horizontal line, the slope is equal to 0. So that means from x to 2 to 8 is equals to f prime of x equals to 0. The velocity equals to 0. So the graph should be from you spinning up and then going down. At 2, going to be a 0. I'm going to use different colored points so you will be able to see it. Go up your speed and then slow down. And then maintain the same velocity. And then you're going down. Okay, that would be the graph. Alright, what's next question? We have a number 10. Is giving you a function. Use the first derivative, second derivative to draw a graph. Alright, so since we need to use derivative, let's find the first derivative and the second derivative. The first derivative is 3x squared minus 6x minus 9. And then from the first derivative, we can find the extreme point or the critical points by setting the first derivative equals to 0. Then I have 3x squared minus 6x minus 9 equals to 0. So I solve it. X equals to use quadratic formula. S equals to 3 or x equals to -1. Now, Second derivative will help us to identify these critical points, whether they are local maximum or local minimum. So I have 6x minus 6. All right, now plugging into the point, double prime 3 equals to 6 times 3 minus 6, which is greater than 0. We don't really need to know the exact answer. We just need to know whether this is greater than 0 or less than 0. Because all we care about if this is concave up or concave down. If it's greater than 0, that means it's going to be concave up. If it's concave up, that means we're looking for a minimum here. All right, oops, doing the same thing. F double prime of -1, I have 6 times -1 minus 6 equals to 0. Okay. Wow, this is, oh, -1, sorry. I calculated that wrong. So 6 times -1 gives you a -6, minus 6 gives you a -12. So which is less than 0 is concave down, which is local maximum. Now we need to find the value of the function. I have f of 3 equals to 3 cubed minus 3 times 3 squared minus 9 times 3 minus 5 equals to -13.2. And then f of -1 equals to -1 to the cube minus 3 times -1 squared minus 9 times -1 minus 5. This is equals to 0. All right, so now we can start graphing our map. We have 2 points at 3, -13.2, which is, let's say, around here, 3 and -13.2. I'm not looking for, on your homework, I'm not looking for like a very nice, precise graph, but I'm just looking for a general graph that makes sense, showing everything that you've known. Okay, another one is at x equals to -1, 0, which is here, -1, 0. At that point, it's going to be our local maximum, local minimum. And we know that at that local maximum point, we have a concave down. At our local minimum, we got a concave up. So we're looking at the graph look like this one. Okay, so now use this method to complete number 11 and number 12, because these two are not hard. Now I want to show you how to do number 13. 11 and 12, do it by yourself. Similar way to do number 10. Number 13. Number 13 is giving you a function, r of t, 2 over t squared plus 1. First thing is use the first derivative. I know we need to use the quotient root. So quotient root is what? Now let's do a quick review. I have fx equals to g of x over h of x. If I want to take derivative of f of x, this should equal to g prime of f times h of x. Oops. So here's the quotient rule that we need to apply in these questions. So I have, oops, let me use the blue pen. So I have 2 derivative times t squared plus 1 minus 2 times t squared plus 1 derivative, and then t squared plus 1 square. When you simplify it, it's not hard because 2 derivative equals to 0. Everything multiplied by 0 gives you a 0. And then minus the derivative of the second one, which is 2 times 2t over, we don't even need to simplify it. We can just keep it that way. So this is equal to negative 4t over t squared plus 1 squared. Okay, now we want to set the first derivative equals to 0. Then I have the first derivative equals to 0, equivalent to negative 4t over t squared plus 1 equals to 0. Well, if you have a fraction equal to 0, that means the numerator equals to 0, because 0 over 100 equals to 0, 0 over 18a also equals to 0. As long as the numerator equals to 0, it doesn't matter what the denominator is. The denominator can be negative 1.3411 over 0. They still give you a 0. So that means we don't need to worry about the denominator. If the fraction, the whole fraction equals 0, that means negative 4t, the numerator equals to 0. So that means t equals to 0 is our critical point. Now, we still need to test that whether this is a maximum or minimum. Now, we take the second derivative. Again, we need to apply the quotient rule. So I have negative 4t prime times t squared plus 1 square minus negative 4t times t squared plus 1 square prime over square the bottom. That gives me a 4th power. Okay, the first one, not hard. So when you take in derivative, you equal to negative 4t t squared plus 1 square minus negative 4t. We can simplify it by removing the parentheses. So I have a plus 4t. Oh, not 8t, 4t. Okay, now this guy needs to take derivative. We need to apply chain rule in here. So in chain rule, we have 2 times t squared plus 1 and take the derivative inside the parentheses. So we have 2t. It looks very complicated, but you know that the calculation is not that hard. You just need to keep track on every step by writing it down nicely. If you write a very mess note, it's very hard to follow. Okay, so I have negative 4 t squared plus 1 squared plus 8t, and now I still need to times 2t, so totally I have 16t squared. I know that looks very intimidating, but don't worry, because remember that we just need to plug in t equals to 0 into the function to calculate that. All right. So next is calculate that. When t equals to 0, so I have r double prime 0. I have negative 4 times t 0 gives me a 0 square gives me a 0. So that means in here I got 1 square plus 16 times 0. Everything in here just a 0. It doesn't matter what it is. because 0 times everything gives me a 0. 0 plus 1 gives me a 1. 1 to the 4th, also a 1. So in here I got -4. So it's a concave down. If it's concave down, that means it's going to be a maximum. Now we need to plug this back into the original function to the 4th and calculate what's the maximum value. I have 2 over -4. Oh, I don't like that. How can I delete that? I'll just draw here. 2 over 0. Sorry, x equals to 0, not 4. So r to the 0 equals to 2 over 0 squared plus 1, which is 2. So the maximum is at when x equals to 0, y equals to 2. So here is the graph. 0 and 2. Since this is going to be concave down, because it's negative, we're looking at a concave down. So your graph should look like this way. Okay, so that's it for these homework questions. If you have other questions that you would like to go over with, please let me know.